one update, Julie Buckner said that she went on the Insight site and it says early registration ends February 25th. So you might have an extra week, people. Woohoo! Okay. So my name's Fred Zelhart. I'm with CodaBears, and I'll be walking through some SQL administration kind of tips and tricks. Kind of did this as a way to get people familiar with some of the basic things that you should be concerned about, so that you at least are doing what you can with your SQL here. There's the agenda, blah, blah, blah. Moving on. The big thing about SQL is don't be afraid of it. It's not out there to kill you. It's not going to harm you. And you do need to know how to manage it and do some basic things. But in general, if you set it up right from the start, you're good to go from there on out. And it just needs a little bit of monitoring as opposed to you've got to check something. Along with this, don't ignore it. If you ignore your SQL, you are setting yourself up for a disaster sooner or later. Later might be 10, 15 years from now. But if you don't take care of some things, they will come back and bite you eventually. Just my own experience, I've watched this happen a few times. People that don't take my advice, and then I come back a couple of years and they're like, we got problems. Like, because you didn't do this thing I told you to 2 years ago. So a couple of obvious things that are going to affect your performance. Remember, SQL is the back end for Epicor. So it's your database. If it's not running at its top notch, there's no way Epicor is going to run at its top notch. If SQL is slow, Epicor is going to be slow, guaranteed, because Epicor is not going to be able to pull the data. So that's why you want to make sure that on your server, and this also flows through if you're running separate server for your Epicor from your SQL server, you want to check some of these things. At the BIOS level and at the operating system level, make sure that you have got it turned on for performance, not power saving. Now, there's various things that you can do depending on the server that you have. Sometimes they put these settings into the BIOS, and they're called C states. You want to make sure they're off. As you've gone, if you worked on a laptop, you'll notice that there is a power option to be whether it's better performance or balanced or battery saver. If you're on a server, that power plan is sometimes still there depending on the operating system version. Go check it. Make sure you're running for performance. There's no reason to not give every bit of power you can to the CPUs so that they're running as fast as they can. If you don't, you're just crippling your SQL server. This is my favorite one that I've run into. Yay! Make sure you're running with a blank screensaver on your servers. Several years ago, Windows NT had a wonderful screensaver that was these pipes, and every so often a little tea kettle would pop up on a connector. It was really pretty and awesome. It also sucked the CPU dry. And I got called into a problem where a customer was having an issue. Every so often, their SQL server would just tank. They couldn't figure out why. It wasn't based on a time of day or anything. And I'm sitting there debugging it for probably an hour or so, not finding anything wrong in their setup, not finding anything wrong in performance. And then as I'm sitting there thinking, that they all go, hey, it started tanking again. And I look over and the screensaver is set to pipes. And as soon as I wiggle the mouse, they're like, hey, the SQL server is back up again. Like, any of those 3D screensavers, they look really pretty, they suck the CPU dry. So make sure if at anything, use a blank screensaver, save the CPU for SQL, don't use it for pretty things. A couple other things are the system properties. And I'm gonna jump over here so I can show you in SQL Server where this is. But there are a couple things a lot of people don't know about in system properties. There are two tabs there, advanced, and then there's a check for optimized background services and visual effects. And both of those I want to turn off. So give me a second to log into my SQL Server here. So if I go into system, and this is from control panel, system security system, depending on your operating system version, you can also go start system properties and it'll bring it right up. Otherwise, you have to go to advanced system settings here. And what you want to look at is this performance. Click on the settings button. You'll notice under visual effects, the default is let Windows choose what's best for my computer. Guess what? Animation, animation, animation. Animations are going to suck the CPU out. Adjust it for best performance, turn off all those animations. So that if someone is logged into your SQL server, they've got to apply an update or something, they logged in and they shouldn't have, at least they're not getting all these extra things taken away, causing your CPU drain. The other place to look, advanced. Usually on servers, this will default to background services. I say usually because I've sometimes seen it where it's adjusted for programs, which means whoever is logged in, whatever they are running is going to get priority on the CPU. If it's background services, whatever the background services are, that's going to get priority. SQL runs as a background service, so you want it to get the priority. Epicor, IIS, those types of things run as background processes. They should get the priority. So make sure you have this set for background services, and that flows through both your Epicor server and your SQL server if you're in a split server environment. Also in here, watch me get this wrong because I go to the wrong spot. Under virtual memory, this is where your page file is. Usually this will be totally fine. You can let Windows manage it. But the big thing here is don't put it on your data drives. And you'll see here, Windows has obviously already taken it, and because it's doing managed, it's put the page file on my data drive. If your page file, which is constantly being used for memory overflows, is on the same drive as something that's constantly being used for SQL, your data file, your LDF, your log files, or your tempdb, they're going to be in contention. So your disk system is going to slow down because it's got to write to two things at the same time. So make it easier for Windows, and sometimes you have to turn this off and tell it to be on its own. If you've got a separate drive for your page file, great. Otherwise, put it on your OS drive is usually what most people end up doing and is safest. Close those things out, go back to my presentation. And the big no-no, which you just saw me do, as much as possible, don't log into your servers. There are remote management tools for a reason. If you log into the server now has to draw those screens. It has to draw the UI for that. Again, you're taking away from the CPU cycles that could be used for SQL. So if at all possible, there are remote management tools. For example, SQL Server Management Server or Management Studio. That's a remote tool. Run it on your desktop. Don't put it on the server, and don't log into the server just to run queries. That's a waste of CPU cycles. So make sure you're helping your server run as optimally as it can. Already did the page file. The other thing that I want to harp on is quality endpoint protection, antivirus, malware, whatever you want to call it. You want to make sure that whatever you're using, that it is what I would call modern. Way back in the day, we all had these antivirus softwares, and they would scan everything as soon as it was executed. So when a program got started, it would scan the executable, find out if there was anything wrong with it, and then let the operating system run it. Every time you accessed a file, a Word document in Excel, it would scan that document and then let it go back to the operating system and you could use it. The problem with that is SQL Server is always running. That executable is constantly getting hit. Your data files, your log files, your temp files are constantly getting hit. So if you have an endpoint protection that is constantly scanning those systems, it's going to slow your system down because SQL is not going to be able to access the files until it scans it and returns it back. And as some of you have seen, your Epicor data files can be excessively large. So that file has to be scanned. Every time you write more data, more time to scan that. So the system's going to just keep getting slower and slower and slower. So again, use something that's quality that either does prediction or it scans everything one time and then looks for changes before it scans it again, things like that. Or if you can, some software allows you to do exceptions. So make your SQL binaries an exception, your MDFs, your LDFs an exception, but be aware that when you do that, it's no longer scanning those items for any sort of antivirus or problems with that. So you may run into problems. You've got to weigh your choices and make the best choice you can there. All right, if you're using virtualization, which a lot of us are, and there's nothing wrong with virtualization, I recommend doing it. It's far easier to virtualize a server, and then if you get, you need to increase CPU, memory, things like that, it's very easy to reallocate it. If you get newer hardware that's got a faster CPU, more memory, better disk drives, it's very easy to migrate a virtual machine over to that new hardware as opposed to having to reinstall SQL on that new hardware and start from scratch, move all your databases, move DNS, move everything else. So virtualization is a wonderful thing. If you're not doing it, look into it. It's awesome. But With virtualization, it still runs on a machine. So that's your host machine. If that machine only has 32 gig of memory, and you have a virtual machine for SQL that's running 32 gig of memory, and you have Epicor server running on that machine that has 32 gig of memory, you've now allocated 64 gig of memory, but the host only has 32. Plus, the host still needs to run its own stuff. So typically, Microsoft will tell you, if you're going to have a Windows operating system, it needs to have at least 4 gig of memory or 10% of the physical RAM. So if it had 32 gig, you need at least 4 gig of memory allocated to the OS. And you've already allocated 64 gig of that 32 to your virtual machines. It's just like the 5 out of 4 people think math is hard. You've over allocated. So you're going to end up in contention. Your 2 virtual machines are going to be fighting for memory, and the virtual host is going to be fighting for memory with the virtual machines. So make sure you know how much memory do you have on that virtual server, meaning the host, how much is taken up by all the virtual machines, total it up, make sure that you've still got memory left. Along with that, don't over allocate your CPU. Now, this one's a little questionable. Depending on how hard you're hitting your virtual machines, you possibly can over allocate your CPUs and be totally fine. So if your Epicor instance isn't getting pounded on, your SQL instance, the CPUs aren't getting pounded on, maybe you can have more CPUs allocated to the virtual machines than you really have on the physical host, and you'll be fine. But you need to monitor that. Don't just go out and blindly do it. Take a look. Are the machines over allocated? Are they running okay, or are they always pegged out on the CPU? Is the virtual host pegged out on CPU? So you kind of need to monitor those things and come back and make sure you make adjustments. As you work with Epicor and work with SQL, you might add more databases. You might add more modules to Epicor. You might acquire another company, and that's going to create more users in Epicor. That's going to create more data in SQL. So over time, your demands are going to change. So just because you figured it out today doesn't mean the CPU and RAM is going to be adequate 5 years from now or 5 months from now. If you acquire 6 companies, you're going to increase your demand on those servers. So make sure you look at that when you hit those milestone points where your business is changing, adding modules, adding users, acquiring companies, adding other software that's hitting the same SQL server. Those are all reasons you should come back and re-monitor your SQL server and your Epicor server, make sure they're working properly. In the case of Epicor and SQL, don't use dynamic RAM and don't use dynamic disks if you're using virtual machines. The reason for that is if it's dynamic RAM, it allocates so much and then it grows and then it shrinks and grows and shrinks. Well, the host is having to grow and shrink that RAM allocation based on demand. That takes up time, it takes up resources. The same with the disk. So you'll start out with the disk and then you'll say it can grow and it can grow and it can grow. Well, when it needs to grow, everything has to pause while it grows that size and then it starts working again. That's going to slow things down, especially in a SQL server where things grow as they need to grow. So as you get more data, the data file has to grow, the log file has to grow as it writes more. So make those allocated disks, don't make them dynamic, you're going to see better performance. The same with the RAM. Make it a set allocation. If you need to allocate more or less, power the machine down, change the RAM setting, power it back up, you're off and going. It's a very quick process with virtualization. For Hyper-V, if you're using Hyper-V as your platform for your host, make sure you're using the latest disk format, which currently, to my knowledge, is VHDX. You're going to get some benefits off of that, bigger file sizes, better performance, better things for transferring between virtual servers. If you're using virtual for your SQL server, and actually on your physical servers as well, if you're using a physical SQL server, you should be aware of this. Make sure you're using CPUs that are appropriate for your version of SQL. If you're using SQL standard, it can only reference the lesser of 4 sockets or 24 cores. So if I've got 6 sockets allocated to that machine, it's only going to see the first 4, regardless of the number of cores. If I've got 4 sockets and they each have 8 CPUs or 8 cores assigned to them, it's only going to see the 24 cores. You can't go more. It's just the way standard is set up. So now you've allocated more CPU resources to a virtual machine that it's not going to use. Bring those back, dial it back. Sometimes this requires you to change how you've organized your CPU allocation on the virtual machine. You might have to change it from being 4-core or 4 sockets. You have to adjust the NUMA nodes, things like that, so that it gets back to where it's 4 sockets, no more than 24 cores. If you're using SQL Enterprise, the limit is going up to the operating system maximum. So whatever the operating system can use for cores, that's what SQL Enterprise can use. Sounds great until you look at the price tag for Enterprise, and worse when you look at the CAL licenses for Enterprise. Some people, it's not a sticker shock. For some of us, it's a big sticker shock. So just be aware of that.
Fred, you have a few questions that are already accumulating.
Okay. So for Aaron Schaefer, add an NVMe drive in one of the PCI slots and put the swap file on there. Yes, that would help you out. Don't put data on the NVMe because it's not redundant. NVMe is going to be faster than your current SSDs, and that is correct. So it's a good way to get a fast page file system for yourself. Joe DeWitt, what is recommended for setting up virtual disks if you have a new system with 24 SSD drives? Well, Joe, we're just getting to that. So if you could hold that thought, we'll get there. And Mel, for replication, I touch on that at the end. So if we can hold that one. And what do I recommend for using raw iron, no VMs for SQL servers in Epicor? You can use direct SQL, meaning a physical machine for Epicor. My thing is, I can buy for a relatively cheap price a huge server, and it's going to have more cores, more memory than I can allocate to either SQL or Epicor. So I'm better off cost-wise making that a virtual host and putting 2 virtual machines on it, one for SQL, one for Epicor, or combine it if you're a small enough company, or you don't have enough, a huge number of users, then you can use a single SQL server and Epicor server, do one server for both. The advantage of that is hardware goes out of date every 3 to 5 years. There's faster CPU, there's faster memory, there's faster disks. So again, in 3 to 5 years, I could buy better quality hardware, again, make that a virtual host, migrate those servers over to that virtual host. They now get a faster CPU, faster RAM, faster disks, and I didn't have to do anything. I just migrated over, and you can do live migrations. So to your users, if you're a 24/7 shop, they're not going to see anything flip. It'll still be the same SQL name. It'll still be the same Epicor name. It'll just start using that faster gear. Also, if I need to apply updates to those machines, Windows updates, typically a virtual machine reboots far faster than a physical machine. So again, I can do faster response for my users. I can do a better service, better uptime for my users than what I could with a physical machine. The downside of this is, obviously, I also need to apply those Windows updates to that virtual host. And when I do that, I need to take all the virtual machines down if I'm going to reboot that host. So be aware of that, and that's going to cause your schedule outage. And if it's got a significant amount of memory, that could increase the amount of time it takes to reboot that machine if it's scanning the memory. Now, there's sometimes you can turn off that memory scan. That's going to speed that up, depending on what other hardware it's got in there. It may slow down as it boots up the BIOS. So just be aware of those things so that you can figure out your schedule. But that's my personal preference because I can always migrate the SQL Server to newer, faster hardware, stay up to date on fastest hardware, and I don't have to do anything underneath. So if I were on a physical server, I'd actually have to reinstall SQL, migrate my databases, migrate my connection for Epicor over to the new server name, or go into DNS and create an alias and switch it over that way. Either one would work. Matthew Heck says, no outage with N+1 hypervisor architecture. Woohoo! There's a solution for you too. Okay, over to disk configuration. So this is physical disks, which would apply to if you're on a physical machine or the virtual host is going to be physical still. So typically what I recommend, RAID 1, which means mirroring for your OS drive, and sometimes for your LDF file, which is your log data file in SQL. The time that you want to use mirroring for your LDF to help with performance is if there's one database on your SQL server, and then that log file goes specifically to that mirrored drive. The reason being is because it's an LDF file, it's written sequentially, meaning it starts here and just keeps going this way. So it's never going multiple spots on the disk back and forth. So with mirroring, I'm writing to 2 disks and I can keep going that way. And if they're physical disks, the heads of the disks stay right where they need to start writing from the last time that they wrote. So it makes for the fastest thing. Now this is if you're doing extreme LDF performance. So we're talking people that are like Google, Google searching, Google indexing, they would be doing this type of thing. For a typical Epicor installation, I would put my LDFs on a RAID 10. RAID 10 uses mirroring and striping. So you're going to get the failover of mirroring so that the disk, if a disk fails, it'll just use the backup. You'll get a warning. You can then hot swap that bad disk and things will rebuild. The striping is going to give you faster performance. So instead of writing to one disk at a time, it's writing to all the disks at the same time. So it's going to get faster reads and faster writes. RAID 5 is another type of solution. You're going to get slower writes. You'll still get good reads, but you're going to get slower writes. So if you're looking for a fast performing system, spend the money on the extra disks, go to RAID 10. You'll be a lot happier in the world. Okay, come on, click. Also on your physical disks and also on your virtual disks, make sure you're using 64 allocation blocks when you format the disk. You can do that in your RAID system, and you should. You also must do it at your operating system. So when you format the disk in Windows, it'll ask you how many allocation units per block or something like that. Make sure it's set to 64 if it's a SQL server. The reason being is that for large files, it's writing in larger chunks, it's going to get better performance. If you don't do this when you set up the disk, the only way to reformat this to 64K allocation units is to literally reformat the drive. So you have to move things off the drive, reformat it, move them back on. So it's going to get a little bit sticky, and it's just better to do it correct from the start. And Aaron Schaefer, in regards to RAID 10 arrays, if you've got 8 disks available, you get better performance with 2 RAID 10 arrays of 4 disks than you would from 1 array of 8 disks. Okay. Depending on the hardware underneath, you could see different performances, but typically a RAID 10, it's going to get you good performance regardless of how it's configured up there. And it may depend on your backplane too. If it's a dual channel, because then the disk can go through both channels as opposed to one channel. So you might run into some different things with hardware that can affect that performance.
Yep. Older hardware was generally around a 1 gigabit backplane. Most hardware that you're purchasing now in the current year, past 2 years, is going to be 3, 6, or 12 gigabit for writing back and forth. SQL and Epicor 10 are intense I/O. So the faster the backplane, the better your performance is going to be.
Okay, if you're using physical disks, set up separate drives or partitions for your data file, log file, tempdb, and backups. Even if you're virtual and even if you're using SSDs, I still recommend this simply because it saves on confusion. If your SSDs, there's an argument that things are instant access because it can go directly to where it needs to be on the drive. So you're not getting the same thing as if you were back on the old platters where it had to scan and move the heads around. But I typically do it simply because it's far easier. Let me bring up my SQL Server here. I've got to log in because my screensaver kicked on. So I'll typically have my OS drive, a data drive, log file, tempdb, and if I need it, I would have a backup drive here as well. Now I back up to a network store, so I don't have a backup drive. But what this lets me do is I can very quickly see, oh, this is where things need to be. As well, when I set up tempdb, I set it to be a specific size, use up all that drive except for 10% so that Windows doesn't complain about running short of disk space. And that's the size tempdb is. I don't let tempdb grow. I allocate everything I need for it right off the bat so I don't have to worry about allocating and slowing things down if I need a larger temp.db file. The other thing with this, and I think I have it later in my presentation, is do things at a very shallow level for your folders. The default for SQL is it starts putting on the data drive, it goes into program files, goes into Microsoft SQL, goes into MS SQL 11.ms SQL, goes into a data drive. Windows has a limit of 260 characters for a file path, if you're not aware. The longer the file path is, the shorter things have to be when you get down to the file name. And the more clicks you have to do to go to find stuff. For me, I go to my data drive, go to the data folder, boom, here's my files. So I'm done. It's very easy to find them. It's very consistent. I can get to them quickly if I need to. And the reason I'm concerned about getting to them quickly is because if something goes wrong, I want to find those things as quick as I can. I don't have time to go hunting around for where did SQL put it. Because when something's crashed, I have to go quick so that things can get back up. And I'm already going to be stressed out because things are down and people are losing money. So I try to make it as easy as possible for when and if that does happen. I kind of approach the problem as, I know it's going to happen. You're going to have an outage. There's going to be a problem. So if I architect things from the start so that I'm ready for when that happens, it makes my job easier for when it does happen. If it never happens, awesome. I've got several customers never have a problem with SQL. I've had some customers that have had problems with SQL, but because I've got things organized right, I can get them going quickly. It makes it very easy. So always think of the future. Don't think about, oh, for right now, I'll just take the default. The default is there for a reason. It's a default. Doesn't mean it's the best choice. So make sure you consider those things. That was the store things in a high level forward. Also, turn on instant file initialization unless you're DoD or you have security concerns. So when SQL has to grow, what it does is SQL makes a request to the operating system. The operating system says, hey, I'll give you this chunk of file space, gives it back to SQL, and then SQL goes in and writes in all zeros, all ones, all zeros. It may only write one or the other, I'm not sure, but let's just say it writes all three passes. Instant file initialization, what happens is SQL makes a request to the operating system gives a chunk back, SQL starts using it. So you're done. So it saves 3 passes of writing to that file system. So you're going to get your file faster, SQL is going to start responding faster for that database, because while the database file has to grow or a log file has to grow, until it's returned back to SQL, all those zeros and ones are written, your database is on hold. So this also gets into if you're growing with very large files, if you've set your auto growth to be large, it takes longer to do all of this. So it's going to take longer for your database to come back online. Now that might be just a second. Nobody's going to notice it, but it's a second versus a millisecond. It makes significant difference when you're trying to make things very performant. The reason I say don't do this if you're DoD is because if you're DoD, there is a way in SQL, because it just took that disk space, allocated it to SQL. If you know the right commands, which again, you'd have to be a SQL admin to be able to get to your SQL server to write these queries, you can come in and you can directly access the disk and find out what was written in that spot of the disk. So you could get to some sensitive information potentially. DoD, I always tell them, because you've got to be concerned about security, don't turn on instant file initialization. If you're not DoD, be aware what the security risk is. Does it impact you? Do you have other things in place that are going to prevent somebody from getting access to that level of your SQL server? And if so, turn instant file initialization on. You're going to have a faster performing system. So it's very nice to do if you can take the security risk. Okay, some SQL things. Memory, don't be a hog. What I mean by that, and now hopefully I will quit using the remote desktop and I'll show you how to do things from SQL Management Studio. If I come in here to my SQL server, go to properties, come down to memory, this memory is what you want to be concerned about. By default, this is something like 2,444,000, I don't know, whatever. It's a huge number. And most people don't ever change it. What it means is that SQL is going to try and use that much memory on the machine. So remember how I said don't be in contention. You don't want to over allocate memory between your SQL virtual server and your Epicor virtual server, or they're going to be fighting for that memory. The same holds true regardless if it's a physical or virtual machine that's running SQL. This number tells SQL how much memory can it use. You need to, again, allocate what is the memory I've got for that virtual machine, allocate the greater of 4 gig or 10% of that RAM for the OS. Whatever's left, that's what I can give to SQL. And SQL will use more than that. Now, if you're running SQL and Epicor on the same box, you might need to take that number down again so that Epicor's got memory to run, because it's going to still need its own memory to do. And in a production environment, I typically tell people count on 32 gig of memory for an Epicor instance. That's in production. If it's your test or your dev environment, you can get away with a little bit less. Even though I tell you that number, monitor that. If you find you need more memory for Epicor, it's running short of memory, give it more memory. If it's not using that much memory, maybe you can dial it back. This is something you have to monitor because based on how you use the system, you might need more or less resources. It's just the way the system works. If you're 5 people and use everything in Epicor, you're going to need a lot of memory. If you're 100 people and only use GL, you might not need a lot. So it just kind of depends on what you're using out of the system. This is in megabits. So remember to take whatever number, if you're calculating in gigabits, because that's what RAM normally is, take it times 1024, put that number in here. That's why this looks odd, but it's around 64 gig is what I've got allocated for this machine. All right, jump back to my presentation. Where'd you go? There you are. Okay. SQL has the capability to do what's called instances. So the nice thing when this first came out was, you can run 2 versions of SQL side by side, and they can be different versions of SQL. You can have one for your production management, one for your dev. It'd be great. It's terrible. Don't do it. The reason being, the instance has a name, and it's very confusing to figure out what that name is. So most people just go to SQL. You're done. Don't go to SQL / whatever. It's going to cause problems with your SSRS because, again, it's going to be a name, which means when people typically tell you go to your SSRS server / reports to get to your reports folder, it's not going to be there. You're going to have a different thing like reports _ instance name. It causes 2 instances of SQL to be running. It causes 2 instances of SQL to be installed to the disk. So now I'm using twice as much memory, twice as much disk, twice as much CPU because it's going to be running. Just put all your databases inside of SQL. If you need a second instance, spin up another SQL server. It's relatively cheap, all things considered. So that's going to save you a lot of time, a lot of money, and a lot of headaches. Set up SQL Mail and SQL Agent. Ooh, I got to start picking up the pace here. I may not get through everything. SQL Mail was designed so that you can get notifications about things. SQL Agent is designed to also run background processes on SQL. So occasionally you have to run backups, run maintenance plans. That's what the agent does. Agent and Mail work together. Agent can notify you of things by using SQL Mail. Let it do so. You don't have to come in and keep monitoring SQL. A lot of it, if you set it up to tell you what's happening, it'll do so. So take advantage of those things. Auto growth of files. If you're dealing with a data file, let it grow in 256 meg chunks if it's going to be a large database. Epicor is a large database, by the way. Your LDF or your log file, grow those in 128 meg chunks. The reason being is that's kind of what people have determined. If it's a large file, you're going to get a big enough chunk back that you can reasonably write to that before you need to grow again. And if you need to grow, it's a relatively small chunk that you can grow quickly, even without instant file initialization. So this lets you grow quickly if you need to, and gives you a chunk that you need. If you're going with a small chunk of growth, then you have to keep growing. You're going to use that space up very quickly. So you're going to keep very frequently have to regrow your files. If you try to grow huge, you're going to slow the system down for longer as it allocates that file space. So that's why you want to keep things in kind of a relative terms. Do not, in Epicor, grow by percents. The reason being is as your Epicor grows, so you're 100 meg right now. So if I'm growing by 10%, I'll grow by 10 meg. So now my next size, I'm now 110 meg. So now I'm going to grow by 11 meg. Now I'm 131 meg for my data file, so I'm going to grow by 13.1 meg. When you get up to a gig, now I'm growing by 100 meg. When I get up to a terabyte, now I'm growing by a gig. every time I need to grow. So your file size keeps getting bigger and bigger every time you need to grow. It's not consistent. And as it grows bigger, it's going to take a lot longer to allocate 1 gig of storage than it does to allocate 256. And how long does it take you to fill up that 1 gig of free space? So it might be sitting there for months before you need to allocate more. So you got to weigh these things so that you're getting good performance. TempDB files. Make sure you've got a number of TempDB files equal to the number of CPUs you're using, or 8, whichever's lower. Microsoft will tell you this. So when I come into my TempDB, which is in my system databases, go to my TempDB, right-click Properties, I go to my files. You'll see I've got 8 data files here. So I've got 8 cores allocated to this SQL Server, so I've got 8 files. Make sure they're all the same size. Make sure they're all set to the same auto growth, which for me on a TempDB should be none, because I've got my TempDB on its own file system or its own disk. So I just give it the entire disk less 10%, so Windows doesn't complain, and I let it just allocate all that in one shot. I don't need it to grow while I'm working on other things. All right, max stop, that should be set to 2. Just a second here. And with SQL 2019, I'm not sure about earlier versions, you can now set this in setup. So Epicor, Microsoft will tell you this needs to be a certain number, like half of the total CPUs you've got allocated for SQL. Epicor has taken their system to the SQL labs with Microsoft, and with Microsoft supervising the testing and everything, this isn't a number that Epicor just came up with. They did work in conjunction with Microsoft. They came out with, this should really be 2. Your cost threshold for parallelism, by default, if I remember correctly, this is set to 5 when you install SQL. Please up it to 50. What this does is it says how expensive is a query before I try to put it on multiple CPUs. And there's overhead with trying to schedule a query onto CPUs. So you want the query to be significantly expensive so that it's worth more than the overhead of scheduling that before you try and put it on multiple CPUs. So that's where you come out. 50 may or may not be large enough depending on what you're running. So again, something to monitor your CPUs, make sure things aren't getting blocked, deadlocked, and starved. SQL, you always want to use Active Directory groups for security. Do not, unless you have a really, really good reason, put individual users in SQL Server. Always use groups. The reason for that, Betty's working and she's got access to these 6 databases, and now Betty leaves the company. If I take her out of the security group, I'm done. I do that at the Active Directory level. It affects her file permissions, her SQL permissions, everything. If I instead have her as a single user inside of SQL, now I've got to go in and clean up SQL. If somebody comes in and takes over Betty's role, I can add that person to the same group Betty was in. They've now got the same rights in SQL that Betty had. If instead Betty was a single user in SQL, I have to go into SQL and basically duplicate Betty. And the more databases Betty had access to, that's the more stuff I have to go in and allocate. So you're just creating a nightmare for yourself. So take it easy on yourself. You've got other things to do. Don't shrink your databases unless you know why they grew large. This is a huge thing. I've seen people with maintenance scripts that go in and every Sunday they go and shrink the database. Well, if you don't know why it grew, why are you telling it to shrink? Usually in your weekly maintenance plan, you're going to do a reindex. That is going to be log file intensive, and that's the thing that people typically shrink back. If it grew the log file on Sunday and because it needed that space, guess what? If you shrink it back on Monday, next Sunday rolls around, it's going to have to grow again. And on Monday, you're going to go back and shrink it again. That's disk intensive. You're doing this. And if you've got SSDs, guess what? There's a limited lifetime for SSDs. They can only do so much, so many reads, so many writes. That's a theoretical limit, but it's out there. Have SSDs outperformed the theoretical limits so far? Yes. But everyone's telling you there is an expected lifetime of an SSD. So make sure that if it grew and you're going to need that space again next week, just leave it out there. It's going to have to grow anyway, so you're going to lose the free disk space on Sunday anyways. So just leave it out there. disks are cheap. If you're running short of disk space, get more. It's just worth the extra money to buy the disks and get the disk space. Don't be cheap on this. Implement your maintenance plans. Make sure that you're checking integrity, defragmenting indexes, which if you're using Epicor, there are certain tables that you can't defragment. You have to rebuild the index. This is why I advocate using, there's a gentleman called Ola Holmgren. He's got reindex scripts. And what they do is they look at the table, figure out if it truly needs to be reindexed or not. And can the table be reindexed or does it have to be rebuilt? It will also update your stats while you're doing this. So take use of those scripts. They are far less invasive. They also will run a shorter time period than if you just blindly use the default SQL task to rebuild everything. Even with SSDs, I would still have it reindexed. SSDs, there's no head spinning back and forth. So the theory is, hey, I can have direct access to the point on the box. I'm not going to have to move the head around. So I'm not seeing the benefit with reindexing that I used to do with the platter systems. I've still seen it have a performance boost. So I still run the reindex every so often. If nothing else, it updates the statistics on the tables, which helps the queries run faster because now it's got better information about what data is stored. So it's a twofold thing that you're doing. You're not just reindexing, you're also updating statistics from your tables, which is the next thing, update statistics. Also, cycle your SQL and agent logs. So if I go into SQL, you may not have seen this before. Watch, I'll probably forget where I put these. Down in management, I've got SQL logs. And I think by default, it keeps 4 or 5. I usually increase this to 10 or 20 because every time you restart SQL, it recycles the log. So you've got a new log. You would think that'd be great. Hey, I can run for months and it'll just use the same log. The problem is if you run for months with the same log, that log is huge. And if you try to look at that log, it's going to take extra long to bring that log file up and look for what the problem is. So if the problem happened yesterday and you're looking at 3 months of data, guess what? It's got to load 3 months of data in before you can look at yesterday. If you only look at a week's worth of data, it comes up relatively quickly. So again, this goes to that concept of I'm looking at for when your server crashes, how can I quickly affect it? If I've got to look at a year's worth of data before I can find yesterday, it's going to slow me down. If I only have a week, it's going to speed me up. So there are logs on both SQL Server and SQL Agent, and you can cycle both of those as part of your weekly plan. Go ahead and do that. I also highly recommend run what's called, whoops, sorry, went the wrong way. Run what's called SpBlitz. This is from a gentleman called Brent Ozar. He's by far an expert on SQL Server. And I mean a current version of SpBlitz. SpBlitz will actually tell you if it is out of date. If it's older than 6 months, it'll tell you to download a new copy. SpBlitz will look for things that are going to go wrong with your SQL Server. So this will tell you, hey, there have been data file shrinks that have been going on. Are you aware of that? There's been DBCC check DBs running. Are you aware of that? Certain thresholds are being hit. So you want to come back and look at those things and be proactive. Got a question from David Height. Sometimes Blitz recommends creating additional indexes. Would creating those indexes impact Epicor application? Yes, it will impact it. Whether that's positive or negative, I don't know because it depends on what you're using and what the index is. Sometimes you're using the system different than, remember, Epicor is a general application, okay? And they put indexes out there for the general populace. You might be using a certain part of the system a certain way that additional indexes on those tables could help you. Also remember that as you write more and more indexes, that's going to slow the system down because when you write to those tables, it has to update those indexes as well. So this is kind of a twofold process. You're making things faster for retrieval, you're making them slower for doing updates and inserts and deletes. So you have to weigh that as well. I always do the caveat. You're putting something out there and you're manipulating it, and Epicor didn't tell you that that's a good thing to do. So if you need to send your database up to Epicor and they see something suspicious, hey, why did you add this index? You're going to need to explain that to them. Be ready for that. It's not that the indexes are bad. You could be using the system in a way they didn't test for, or they assumed, hey, it's a very small percentage of people that are going to use this. So putting that index in is going to slow down 99% of the people that use Epicor. But in your case, it might help you. So just be ready for those types of explanations if you do need to send your database up to Epicor. Be upfront with Epicor. If you upload your database and you know you've added indexes, tell them upfront, hey, I added these things because I did some analysis and this helped me, and I did see performance improvements. You're being upfront. It's going to help whoever's supporting you to go, oh, I know that stuff's there. If I see I'm probably not going to look for other odd things, but if I find something on my own and a customer didn't tell me, I would be going, okay, what else did you do to the Epicor database? Did you go in and directly insert data into the tables? And we all know that causes problems. So if you're upfront, I think you're going to find a very good support experience. But if you don't tell those people that you added those extra things and you don't have them documented, you're going to have some problems. As well, Epicor could, I'm not saying they do, but they could come out with a patch or an update, and it may recreate that table because for whatever reason, they needed to re-architect the table so it's got a better speed performance. So if they re-architect that table, that may take your indexes away because they recreate the table from scratch. So if you don't have documented what indexes you added, that patch gets applied, you lose your indexes, you lose your performance. And if you don't have it documented, you can't easily recreate it. So make sure those things are documented so that you've got it going forward. And I have reached the end of my time. If everybody's ready, I'll just keep going because I think I've been answering questions as I go. A couple other things you want to check for SQL backups. Make sure you understand what a full versus a simple recovery model is. There's a white paper on that. I've got it at the end of the presentation, and when I distribute the notes, that'll be in there. Make sure if you are doing a full recovery model, you're doing T-log backups. If you don't do a T-log backup, your log file is going to keep growing out of control. And if it keeps growing, it's going to eat up disk space. If you do a backup, it grew to a certain size, and then it empties it out when you do the backup. Make sure you know when your backups are supposed to happen and that they are happening. If they are not happening, figure out why. Know what, if you're using a third-party software, make sure that it is on your full recovery models doing T-log backups. I've seen a lot of people do an installation of a backup software that starts with a V. I'm not saying that software is bad. It seems like it works wonderfully well, and I'm sure it can handle T-logs. I haven't dug into it enough to figure out all the settings for the T-logs when it does it. But by default, that software will truncate the T-logs. What that means is you have a full backup and that's it. You don't have T-log backups. And the whole purpose of doing a full recovery model is so that you can restore to what's called a point in time. So if I needed to restore to 11, 12, and 32 seconds, I can do that, but I need my full backup and I need all my T-log backups until that point in time. So if they get truncated, there's no backup. All you can do is restore to your last full backup, which hopefully is last night. So be aware, know what you're doing. If you're backing up to a file system, make sure you've got compression and checksum turned on. Checksum's a great way to at least do another check on your backup to know if it's good or bad. But again, I'm going to skip down. The only good backup is one that you've restored. If you haven't tried restoring your backup, you have no idea if it's good or bad until you got to restore it. And make sure you know the process for doing that restore, because the time to find out that you don't know how to do a restore is not when your SQL server goes down and you have to. You want that process documented. You want to know where that document is. In fact, print it out, have it sitting in a drawer so that when this happens, pull it out and with a pen, start crossing off the steps as you do them. Because you're going to be flustered. You're going to be trying to work quickly. And if this isn't something you do every day, it's going to be a headache to do. So make it easy on yourself. Plan for when the failure happens. This 3-2-1 backup strategy, what that means is you want 3 copies of your data. You want the copy that's on your server, and you want at least 2 backups. Those 2 backups you should have 2 backups on it. You should have 2 copies of your data on different media. So a USB drive and a tape drive, physical disk and something else. You want it on 2 different media so that if whatever reads that media dies, you can get it from the other copy. You always want to have 1 copy of your backup off-site. so that if something happens with your place burns down, you can still recover. You may not be able to recover to 5 o'clock last night because the fire started at 7 at night. You didn't get everything out off site, but you can restore to yesterday. All right. If you're going to use stored procedures for your own stuff, if you're writing your own reports, make sure they go in their own database. SQL also has default reports. Bring that up real quick, just because it's kind of nice. Scroll up to the top, Fred. Chung, 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 chung. There we go. So I can just come to a database and I can do reports. There's standard reports out here that SQL does. I can just bring that up, and it uses SSRS to do this. So I can find out how long do backups take. There's things like that that tell you what are your most used tables, your most used indexes, things like that. You don't have to write the SQL to get there. You can just find it by using the standard reports. Reports are available both at your database level, and you have reports at the server level. So you can get some cool information, and they're nice looking reports. Woohoo! All right, flip back here. What else do we have? Query store. So this is a new feature, I think starting in SQL 2016, I could be wrong. But what this does is while SQL's running, it keeps track of all the queries that are running and kind of adjusts itself based on patterns it sees. That information gets flushed when SQL restarts. SQL Query Store actually writes it to disk. And all you have to do is go under your database properties query store, set the operation mode to read write, boom, you're done. When SQL restarts, it's going to read that query store and start using that as the basis for anything that it's adjusted. And since SQL will dynamically make changes based on patterns it sees, whatever you had running is most likely going to start out. So you don't have to run a whole bunch of queries for SQL to go, oh, wait, you use that table this way. So I'm going to add a dynamic index on the fly for you or something like that. So make use of that query store. Still trying to figure out best recommendations for like size, frequency of writes, things like that. So one of these days I'll publish a white paper on that. If you need it, SQL also has things for high availability or redundancy. You can do clustering, which means you've got two servers set up, and one of them set as the SQL server and the other one set there passive, and they are using a shared disk. If this one dies, this one will pick it up and start servicing the database requests. You don't have to change the name, no DNS updates. It'll actually take all that stuff over. You can also set it up that when this one comes back up, it'll take the SQL services back over, and so it goes back to here. This is great for when you have to apply updates. Your SQL literally never goes down. It's down for like 2 seconds while the heartbeat goes, oh, that machine's not up. Flips everything over and you're back up and going. Most likely your users will never notice that. You can also use replication. So I can replicate databases between two areas and do that. And there's a latest thing called high availability groups. So you can actually set up groups of databases that become highly available and can flip between servers. I think, I'm still researching high availability groups, but I believe that also uses clustering so that things can take over. Dan, when we first went live, you provided SQL database backup and restore document. Do I have one for defragging indexes using Hollingren scripts that we can download? I will put that in the notes, Dan. I'll try and make a note here that I can include what I do as a SQL task inside the maintenance plans for the Hollingren scripts. All right, I have 1 minute left. Didn't make it through everything, but I will go ahead and post what I've got out here. There's a couple things on SSRS. Again, use your Active Directory groups where you can. A couple items on SQL queries. Try to make them look pretty, make them formatable, name them correctly. And then there are some tricks with using SP for each DB and being able to use a query that writes a query. So I'll put those queries out in the notes as well. That can sometimes become handy when you've got to iterate over some things or do some things and you want SQL to actually generate a query that you can then run in a query window, because SP for each DB sometimes can't handle complex items. These help links will be out there. Brent Ozar, a link to some explanations on how to do the CPU cores. Epi Users Help, of course. Microsoft Learn will teach you a lot about SQL Server, SQL Docs, the white paper on backup so you can understand that. And also CodaBears does server health checks for you. So if you need somebody to go in and look and make sure SQL's running and Epicor is running properly, that's kind of something you can use.